So I will start from the basic so that it will build the uh, build a block so that you can learn the thing from the scratch, and later on this will be very helpful for you guys to write your program accordingly according to your need, independent of any package available over the internet. So you can write your own code for your suitability. So we will start uh, with the programming language. So first we start with the program. What is a program? So program is nothing but a notation. It is a notation through which you can communicate the system how to do the task. Notation nothing but the language which the computer is able to understand, and by using this one you are going to you are giving the computer instructions that how it need to perform that certain task. This is the programming. So coming to the programming, we have basically two type of model. We have two type of model. One is value model of the programming language, and another one is the reference model of the programming language. So basically, you have worked with your C, C++, Java. You know about these languages. Yes or no?
Yes, sir.
So these are the languages which work on the value model. In one of the languages, our Python, it works on the reference plus value model. So basically, what is the difference between that value model and reference model is that if I say in value model, I am giving the example. If I say in value model, x equal to 10, what is happening inside the behind in this one in value model? A memory location is created to hold the value 10 over there, and x is pointing to that one. X is pointing to that location. Similarly, if I say x equal to 11, another memory location will be created behind the scene, and now x will point to the 11. Similarly, if I say y equal to 11, another memory location will be created behind the scene, and y will be pointing to that one. This is usually the case in our value model. But what about the reference model? Is that reference model say whenever you are going to create some object in Python, everything is actually an object. I'm not going to detail of that one. I'm just giving the example for that one. So if whenever we are going to declare some variable x equal to 10 in reference model, now y, and I am saying y equal to 10 also, then only one memory location will be created, 10. Now x will be pointing to this location and y will be pointing to this location. Over here in value model, when x and y both are pointing to 11, the two different memory location will be created. But here only one memory location is created on which x and y are sharing this 10 number. Over here, two different variables sharing the different memory location. Thereby, Python is used for, also used known for its memory management, where it saves the memory, because everyone know that whenever we create a memory, so it will take certain amount of bytes, certain amount of space inside your RAM. So it saves the space. This reference model saves the space rather than wasting the space in case of your value model. So everyone got this point.
Yes, sir.
Everyone got this point. Everyone, anyone have doubt? Please let me know. So coming to the next one, we all know that uh, this value model programming or programming language, and reference model programming language. But Python is using your value model plus reference model. It is actually a hybrid mode. I will tell you later in this session how this in this Python value model and reference model are both are working in this one. So in the reference programming model, most of the time, what we are doing in this one, we will be using compiler in value model, and in this one, most of the time we are using the interpreter. So by using this value model, our code is is executing very faster rather than our interpreter model. So the compiler is basically what it do. Whenever in earlier example, if I come to the earlier example, I say x equal to 10, y equal to 10. Since it is creating separate memory location for x, separate memory location for y, both are containing the value 10. So it is not searching if after execution of this first line, memory location for 10 is created where x is pointing. After executing this statement in somewhere in the memory, because your RAM is something like that, it contains huge amount of data. Inside that one, it need to access a memory location which is free so that it can give to your program. Fine? Up to here is fine for everyone.
Yes, sir.
So now, in this one, whenever we create the x equal to 10, y equal to 10, x will be created in some memory location, y will be created in some memory location. Y don't know about the x don't know about the y. But in this case, whenever we create x equal to 10, y equal to 10, whenever variable 10 is created, x is pointing to this one. Now, whenever we will say y equal to 10 in this reference model or in reference interpreted programming language, it need to search in your entire RAM, which are in your entire RAM, whether 10 value is created or not. That's why one of the reason is that this Python is slow than your compile time programming language. One of the reason of this one. So everyone got this one.
Yes, sir.
Everyone.
Yes,
So
sir.
Python basically work with your value model and the reference model. So we will see the example of this one when it work as a value model, when it work as a reference model. Now I will coming to the programming of your Python. So everyone know about this value model of the programming. Basically, first is the program. It is nothing but the notation, and this programming language is divided into two categories. One is the value model, another one is the reference model. The value model says I will be creating new data type whenever it is needed, even though some variables are sharing the same value. I will be creating the separate memory location for all of them. But in the reference model, it say if you are sharing some variable, just make a reference to that one so that we will minimize the wastage of our memory. This is the concept of reference model. Now, Python takes the good thing from both of the world. It manages your memory. It is now in this time you can see the Python is uh, becoming very fast. It can beat it. No, it never beat the things, the compile time language, but it is comparably coming to the nearby speed of the compile time language. So, because of some modification, because it is taking the good thing from both of the words, volume model as well as the reference model. So now I'm coming to the Python programming language. So up to here is fine for everyone. Anyone have doubt?
No, sir.
So in Python, I will be starting with some basic data type. Then we'll move to the advanced data type of the Python, and later we will see the one of the example related to bioinformatics field, where I am designing a DNA toolkit so that uh, later on you can develop the same thing for your project also. So there are various data type. One of the primitive data type basically I'm talking in this one. One is your integer, sorry, it is int. One is float. Another one is bool, that is boolean value. Another one is string, str. And later we will see the another thing, the advanced data type. So whenever we create, as I already told you, x equal to 10 in case of your integer and y equal to 10 in case of our integer in Python. So it will allocate a memory location of 10 to which x and y both are sharing. But in case of your float data type, float means your decimal values also included in this one. Like if I say x equal to 10.5, y equal to 10.5. In this case, memory reusability concept doesn't apply in Python because if you see over here, x will point to 10.5 location, y will point to again another 10.45 location. In this case, memory location is utilized because if you see over here, between, if I say ask you between 10 to 20, how many numbers are there in case of your integer?
Guys, please be interactive.
10, sir.
Am I audible to you?
Yes, sir.
Yes, sir.
Between 10 to 20 in case of your integer, if you see over here, there are 10 numbers are there. 10 numbers are there. And you can see the range is always finite in case of your integer. But if I say you between 10 to 11 in case of your float or decimal number values, how many numbers are there?
Infinite.
It is infinite. So in this case, in case of float memory allocation, because the range is infinite, therefore Python do not uh, use the concept of memory management because the things are infinite over there. It need to allocate the memory or search the memory for very long time. That's why memory reusability concept is not there. But in case of boolean are only take two values, true or second value it will take false. So internally they are represented as 1 and false is represented in form of 0. So there are only two values. So whenever if I say x equal to true in Python and y equal to true, both are pointing to the same location, like as your integer.
Excuse me, sir.
Hmm.
Sir, can you please explain the float concept once again, that why it is not using the same memory location for
Okay.
both the variables?
Okay. Because the range is infinite. Over here you can see the range is finite in case of integer. In case of integer, the range is finite, only 10 numbers are there. And in case of float, between 10 to 11, the range is infinite. And in order to maintain this range, Python need to do a lot of work inside because how it is allocating, if you consider this case, if you consider this integer case, you can see the range is only the finite numbers and between 10 to 20 only 10 numbers are there. Fine. Now, if it allocated somewhere in the memory location, for example, 2000 in memory location, it is allocated this 10 value. So in anyhow, whenever I say x equal to 10, it need to search in, it need to search inside your memory. Then if the 10 is available inside the memory, it will allocate a reference to x. The 10 is available in 2000 memory location. Similarly, when I say y equal to 10, it will search for this memory location y 10 and give the reference to the y. But in case of this one, because the number are finite, because over here number are infinite, so it needs to, so can number can be 10.5, 10.51, 10.50000000 something. At last, there is one. In general term, we can say these are equivalent. But because the precision of this one, first the precision of this one and this one depend on the user. The precision of this one is in some programming context, the precision is very important. So because of this infinite range, it do not search for this 10.5 inside your memory. Because in mathematical concept, you can say 10.5 equal to 10.50000, multiple zeros are there up to 1. Because it need to search the things again and again inside the memory. That's why for float concept, it do not use the memory reusability concept. Fine.
Yes, sir. Thank you, sir.
Now, coming to your string data type, coming to your string data type, this is mainly useful for you guys because of the computational biology or bioinformatics field, because you are dealing with the protein sequence or maybe the genomic sequence. This is very important for you. So if I write one sentence over here, if I say a equal to, in Python, you can write the string in one inverted comma or either in double inverted comma, either in triple quotes. You can write by your own way. Whatever the way you like, you can write that. Now, suppose I'm writing PQR over here. Then if I say B equal to PQR, in this case, also it will maintain the memory reusability concept. Now, PQR is pointing to this memory location, suppose. Now, A and B both are pointing to this memory location. But the case is like that. If I say A equal to hello space, then Python, if I write over here B equal to hello Python like that. In this case, Python will not create the same memory location. Why? The general reason is like that. If you see, this is a sentence. Yes or no? This is a sentence.
Yes, sir.
This is a sentence. Now, suppose I am giving a example of Amazon example I am giving to you. So everyone can able to relate this one. In Amazon, Amazon, you can see there are reviews by the buyers on the product. Yes or no? There are reviews by the buyers. Buyer write the reviews and they give their own rating, as well as Amazon provide you his own rating. Amazon also provide his own rating and buyer's rating is also there. Yes.
Yes, sir.
So
Yes, sir.
in this case, this generally buyer write the review in form of sentences. So suppose he can say this product is good. Some say this product is nice. Some say this product is bad. Something like that they used to say. Now what Amazon do? What Amazon do? They will divide the things in form of tokens. Tokens means a single word from your sentence. they will divide the thing into the single sentence, single word. So this will become one word, prod will become one word, is will become one word, nice will become one word. So whenever they compare the review of two different buyers, they will extract the meaningful word. From this one, the meaningful word related to product is good. Another one is the nice. Another one is the bad. These type of things are there. So basically, it is an NLP problem. I'm not going to going deep on that. I'm just saying, specifying the thing that how Python managing the memory. So in this case, what I told you, in this case, if the sentence containing some special character like space over here, like space over here, like at the rate, some special character like that. So memory reusability reusability concept is not there. So what they do, they divide the thing in form of tokens. Tokens is nothing but the word from your sentence. Now, whenever there is a good inside the sentence, they create a memory location. Suppose buyer one say good, buyer one to up to buyer 100 will say good. They are using the good word in their sentence. They extract that good word, and by using the Python word, Python concept, memory manager concept, the good word is only created one time inside your memory, and all are pointing to this one. Otherwise, if you are using the value model, if 100 buyers saying the product is good, you need to create the 100 memory location in order to tackle that one. And it will waste your space a lot. Now, in case of Python, if you are using, it will only creating one memory location and all variables are pointing to that one, referring to that one. So this saves us space a lot because we do not work with the string, we work only with the token. That's why in the string concept, string concept in the Python, reusability concept only used for the your words, not with the sentence. Because we are only dealing with the words, not with the sentence. That's why they didn't apply the string reusability concept with your entire sentence. Everyone got this one?
Yes, sir.
Yes, sir.
Everyone got this
Yes,
one?
sir.
We used to work with the tokens rather than the string. That's why Amazon provide its own rating based on how many people are saying that product is good, how many people are saying the product is bad. Based on that, Amazon also provide their own rating in this regard. And they do not work because no one used to deal with the entire string of the entire review by the buyer. They only take some useful word from that sentence, and based on that they analyze the thing that whether the product is good or bad. So in this case, because if they are creating multiple memory location for only the good string, that good keyword string, then it will wastage of memory location. So Python come over here to provide some handy thing that you can deal with. You can extract the keyword from the sentences and allocate the space for that keyword. So everyone are able to refer that keyword, and that's why it will minimize the wastage of your memory. This is the concept of your Python. Fine.
Yes, sir.
Now we will see some of the example related to this one, how to check the thing over Python terminal. You can use your Google Colab, you can use the Jupyter, you can use the Jupyter, you can use the Colab. I'm using the PyCharm editor in order to demonstrate the thing to you. So come to the PyCharm terminal. So this is my terminal. So I'm writing Python. I told you Suppose if I say a equal to 10 and b equal to 10 in Python, now I'm saying it is allocated in same memory location. So for that one, in order to extract the memory location, you can use one keyword is there, one function is there, id a, id of a. It will tell you the memory location where that 10 variable is allocated, 10 value is allocated. Similarly, if I say id of b, now you can see these two memory locations are same. These two are same over here. Now, apart from this one, you can also use one operator is there, is operator. It will tell you whether two variables are pointing to the same memory location or not. For that one, is operator is used. If I say A is B, it will say yes, true. If two variables are pointing to same memory location, either you can print the ID value of that one and check that one, or either you can use the is operator. Now, if I say now A equal to 256, B equal to 256. Now, if I say A is B, so it need to print what? Again, if I say A equal to 257, B equal to 257. Now, if I say A is B, then it need to print what? But it will print false. Now, the thing is that the hack is that in this one, in Python, hack is like that because most of the time we are using the why they use this hack over there up to 256 up to 256 memory reusability concept with integer will work. After this one, memory reusability concept will not work after this one because during the experimentation they find out most of the time up to 256 number most of the time people are using in their programming context. That's why that's why up to 256 the reusability concept is there. There are very rare cases or less cases are there, not rare, I am not saying rare. I mean to say that it is very less case. Very less cases are there on which the values is more than 257, more than 256 are used in your programming context. So that's why the memory reusability concept is there up to the integer 256 range. Now the thing is that whenever Python, whenever the Python interpreter load, because whatever the on the screen you are seeing that one is the Python interpreter. Whenever that interpreter load, it will automatically allocate the memory location for those integer up to the range of 256. So if the range is, now you will get the clear notation what I'm saying you why the float is not uh, uses the reusability concept. Now up to the 256 the memory location is created for the values for integer case. Now the for the float case, now the for the float case between 1 to 2, because there is infinite range, it cannot allocate the memory for all of these range because the range is totally infinite. Up to 256 there is a fixed range, but 1 to 2 there is infinite range. Now up to 256 Python compiler is whenever it is loading, it automatically allocate the memory location up to 256, but between 1 to 2 there is infinite numbers, so it cannot allocate all of those things because after allocating the memory location you are able to see your interpreter on your screen. But if it need to allocate the memory from 1 to 2, because the range is infinite in case of your float, it need to allocate infinite memory location and your RAM will become full and it will be you will never see your interpreter on the screen. That's why for the float, the range. That's why for the float, the Python do not use the reusability concept, but for the integer it used. Now in this time it is clear for everyone. First, it will create the values up to 256. Then it will load. Now, because for the float numbers, the range is finite. Now it need to allocate more and more memories. It don't know how many memories it need to allocate. So Python interpreter will always busy with the allocating with the memory for the float number, and it will consume your whole memory. That's why for the float numbers, the memory divisibility concept is not there. Now another thing is that I told you that string. Now come to the string portion. Now, I am say a equal to hello and b equal to same thing I am writing hello. Now I say a is b, it will say true, yes. Now if I say a equal to hello Python, sorry, now again I need to say a equal to. Now if I say a is b, it will say you false, because we always work with the tokens, and your gene is considered, gene string or protein string is considered as a token. Suppose if I say a equal to ttgca now b equal to, if I say the same thing, now I say a is b, it will say true. Now, one of the benefit of this one in your genomic application or proteomic application, because you say you can see that your genome string is just a string, no space is there, no special symbol over there, and it is just a string, like a single value, like your hello, a single token is there. Now, if you are using the gene or downloaded the gene from your NCBI website, and if two gene you downloaded by mistake or uh, uh, by your choice, you downloaded the two genes same percentile, then in this case it will be created, it create only one memory location for that gene if the things are repeating on both of them. Now how much space you are saved by using this one, because you know that genome size is up to billion base pair is there. Yes or no? Below genome size, but
Yes,
I'm not
sir.
saying about the gene. Genome size is up to the base, up to the billion pair is there. So because of repetition in one individual to another individual is there, by using this one, we can save a lot of space if we are using this reference model. So Python is using the mix of both of the word. One is the reference model, another one is your from your value model. Based on their experimentation, they decided up to where they need to provide the integer value, the reusability concept, and up to where they need to provide the reusability concept in form of string. This is the concept of your Python. So up to here is fine for everyone. One thing Python provide you, because I already told you, true is represented in form of 1. Now if I say true, it will return me true. Now if I say true plus true, it will return me true, 2, rather than true or something value. So internally, the true is represented in form of 1. And if I say false, false plus false, sorry, false plus else false, it will return me 0. So the advantage of this one, when you are using this, when we will go to the list data type or some tuple data type, you are going to compare the list, and is nothing but like as your array. Everyone know about the array. So list is nothing but your array type of thing. So in this one, you are putting the element like suppose 2, 4, 6, 8, something like that. Now, if you say or 3, something like that, I want only odd numbers. How many odd numbers are in this list? So in this case, the 3 is odd, it will return true. This one is even 0, 0, 0, 0. Then you can simply say, I just want sum of this one. It will say 1. So by using this one, you can easily say that only one element is there, which is odd. Rather than it will return you the true, false, this type of notation. It will directly say you that by using the numeric value, you can easily say that which one is, how many numbers are odd over there. Because we can sense the thing with the help of number rather than the string in this case. We'll come to that one later. Fine. So true is nothing but internally it is represented in form of 1, and false is represented in form of 0. Similarly, when you say true plus false, it will return 1 because true is 1, false is 0. Now, some of the operators you can know about, know about this thing, like your arithmetic operation, like plus, minus, multiply, divide, mod, double divide is there. 3 divided by 2. What will be the output?
1.5.
1.
1.5.
1.5. If I say 3 double divided by 2, this is also a divide symbol. This is also a divide symbol. Now, this divide symbol will tell you if the number is coming in floating point, it will represent that number in floating point. This will say I will always represent the number in your integer form. If you see the example like this, 3 3 divided by 2, it will print 3.1.5. Now, if I say 3 divided by 2, it will say 1. So, in order to get the value in form of integer, we will use double divide in Python. Everyone got this one?
Yes.
And this one is nothing but the power notation. What?
Power.
This is power notation. So, if I say 3 double multiply by 2, it is nothing but 3 square. Fine.
Yes, sir.
Yes.
Now, the thing is like that, up to where you can use this operator. You know that you can use with integer this one, float this one, these operator you can use. But can you use this operator with string? If I say Python, this is one string plus hello. If this is the statement in the Python, then it will just nothing but the concatenation of two strings. It will print Python hello. You can use this operator with the Python plus, but you cannot use the minus one. You can use the multiplication. If I say a multiply by 3, it will be a. I can use this plus and multiply with the string in Python. If you want to see this one, if I say a equal to hello, and if I say b equal to Python, I can say a plus b in Python. It will say hello Python. Now, if I say a equal to some a value is there. Now, if I say a into 3, it will print triple A. So you can use multiplication operator with the string and as well as the addition operator with the string in Python. Fine. Now one thing is that in Python, the mutability and immutability concept is there. Mutable or immutable concept is there. Up to here we have seen the thing related to memory reusability. Now the thing is that whatever the values you are creating in the Python, they are mutable or immutable. That thing we need to see. Mutable means you can change the thing. Immutable means you cannot change the thing. For example, in Python, if I say x equal to 10, inside in memory location, a 10 will be created, x is pointing to this one. Similarly, when I say x equal to 11, in Python, what it do? 11 is created inside your memory location, and now x is pointing to this one. Now x will not point to this one, x will point to this one. Now in this case, you can see the memory location, reference of the memory location is changed and reference location of x is changed when the value is created. But because the Python is using your reference model or value model, the combination of two. Now if I say in the value model, the same thing if I say in value model, so memory location, inside the memory location 10 will be created. Now when I say x equal to 11, in the same memory location 11 will be override. But in case of Python, the two different memory location will be created. Up to
Yes.
here is fine. Up to here is fine for everyone.
Yes, sir.
Yes, sir.
Yes, sir.
So the mutability concept is generally comes to your value model and immutability concept comes to your Python model. So now if I say x equal to a, b, c, d, some string is there. Now if I want to change x 0 equal to some character, maybe n, so Python will give you the error over here because the strings in the Python are immutable. You cannot change the value of a string. But if I say x equal to abc, y equal to pqr, if I say x equal to x plus y, then it will be abc pqr. If you want to see its mechanism over here, so in this one, x will be created, abc will be created inside a memory. ABC will be created inside in the memory. X is pointing to this one. Now, Y will be pointing to PQR. Now, when I say X equal to X plus Y, a third memory location will be created. ABC, PQR. Now, X is referring to this one rather than this one. If you want to check this one, you can check over here. For example, if I say X equal to A, B, C, suppose I say like that. Now I want to print ID of X. Now if I say X 0 equal to some n over there, it will give me the error because string are immutable in the Python. Now if I say X equal to ABC and then PQR, Now, if I print the ID of X, you can see it allocate different memory location. Just see, in case of ABC, the memory location is this one. Now, in case of when I do the concatenation, memory location is different location. So you cannot change string in the Python because the Python use the memory reusability concept. It may be chance in Python. Why the strings are immutable in Python? Because if I say x equal to ABC, suppose. Now y is also I am saying ABC, suppose. Now in somewhere in middle of my program, I say x equal to x plus t. Now what happened in this one when I doing this thing? In memory location ABC with value ABC is created. X and Y both are pointing to this memory location. Now when I say x equal to x plus t, now if I do the change over here, then change will automatically reflected into the Y also. It may be chance other object are also pointing to the same thing which x is pointing. That's why in order to retain the thing over inside the memory, Python will create a different memory location for this one. Now ABC, T will be there, X is pointing to this one rather than this one. Now all objects are saved with their previous values. Fine for everyone?
Yes, sir.
Yes, sir.
This is the basics of your Python up to here, up to the string, up to your primitive data type. This is the basics of the Python. So Python always retain the use the memory in such a way it will be minimal wastage, and it will use the mutability and immutability concept in order to write your program so that you can use the memory efficiently. Now coming to the another operator like your equal to is there, one equal to is like that and another equal to is like that. This one is for your comparison and this one is used for your assignment. So everyone know about that assignment and comparison.
Yes, sir.
Yes, sir.
So another one is smaller than, equal to, greater than equal to, smaller than equal to. You can use this operator with your integer, float, as well as your string and boolean. So shall I need to explain this thing? In case of integer, I don't think so. I need to explain. In case of float as well. But in case of string, do you need some explanation in this one?
Yes, sir.
Okay. So if I say a string a equal to abc, something like that, and b equal to abc, same thing if I say. So Python, it will, what it will do in backend, if I say a equal to b, a and b are nothing but the variables and abc are the value. So it will check your value one by one. It will check a to a, b to b, c to c. If after this one both are same, it will return you true. If both are not same, it will return you the false. Similarly, if I say a is smaller than b, it will check value by value. A and A, it will compare. No, A and A are not smaller. B and B are not smaller. C and C are not smaller. So it will return you false. Similarly, in case of A is greater than B, similarly A is smaller than equal to B, similarly A is greater than equal to B, it will return you the false in all of these cases. For example, if you write this thing, For example, if you write something A equal to ABC, B equal to ABC. Now if I say A equal to B, it will return me the true. Now if I say B equal to ABCD, now if I say A equal to B, it will return me the false. Similarly, if I say A is greater than B, it will again return me the false. Now if I say A is smaller than B, it will return me the true. So you can use these operators with the string. Fine for everyone?
Yes, sir.
Yes, sir.
Similarly with the boolean, true is smaller than, true is always 1 and false is 0. That's why true is always greater than the false. You can use these operator with your integer, float, string and both these operators. Now come to the logical operators. One is your AND is there, one is OR is there, and another one is your XOR, XOR is there, and okay, up to there is one, and also now in logical operator and or not, sorry, XOR and not. Now in case of AND, in case of your string, first in case of your empty, if whenever you have the empty string, it is considered as false. First, second, whenever your number is 0, it is considered as false. And whenever the number is or whatever the other than this thing which is non-zero, which is that one is considered as true. So whenever we apply this logical operator, we will get, because we use this operator in case of your if condition and looping this constant we are using. So thing is like that. If I say x equal to 10, y equal to 20. Now if I say x and y. So everyone know about this and gate, or gate, not gate. Yes or no?
Yes, sir.
So in case of the Python, whenever, if in this case, whenever x is evaluate to false, then this AND operator result will be x, otherwise result will be y. In this case, if x equal to 10, y equal to 20, now I am saying c equal to something. Now c will be checked like that, x value is 10 and y value is 20. Now evaluate the x value. Each x value is false. False in this case only when x value will be 0 or maybe the empty string. So x is non-zero value. It is true. So it will evaluate to c value equal to 20. If x in case of AND, if x is evaluate to false, then it will return x. Otherwise, it will return y. Similarly, if I say x equal to 0, y equal to 10, now I say x and y. So what will be the output? Can anyone tell me?
False.
Means what will be the output? False or 0 or something? What is that one?
0.
C output will be 0. Because whenever x is evaluated to false, false means either 0 or empty string. The value, whatever the value of x is there, that is assigned to the C. If it is true, evaluate to true, then whatever the value of y, that will be assigned to the C. This is the this is your this case AND case. Now coming to the OR case, if I say x equal to 10, y equal to 20. Now if I say C equal to x or y. Now if x is evaluate to true, in case of AND it is false, then the value of C will be x, otherwise value of C will be y. In this case, if I say C equal to x or y, this example, the value of C will be 10 because 10 is true number. If I say x equal to 0, y equal to 10, now if I say x or y, then it will be 10 because x is evaluated to 0. If you want to see the example, then check over here. C equal to 0 and 0 and 10. Now if you want to print that C, it will be 0. Similarly, if I say OR operator over here, now if I want to print the value of that C, it will be 10. So everyone got the idea of that AND or NOT operator?
Yes, sir.
Yes, sir.
Now one of the thing is that in this one, everyone want to know about the how we can take the input from this from the terminal. For that one, the Python provide you one interesting thing is that input. Input function is there by using which you can take the input from the terminal. Now, suppose if I say a equal to input enter number, if I say like that, and on the screen, I am typing the input 10 suppose. Now, after this one, if I say tell me the type of a, it will always tell me this one is nothing but your string. This one is nothing but your string. But you are considering 10 is nothing but a number. So for that one, you need to perform the typecasting. Typecasting. Typecasting means changing one type to the another. Now, for example, this one you are assuming that one is an integer. That's why you need to tell Python the input in this format. A equal to int input, whatever your message is like that, enter number. Now, A will be whenever you print the type of your A, it will print is nothing but as integer. For example, if I say A equal to, I am taking some input. I am saying enter number. Now I am entering some number, suppose 10 I am entering. Now I want to check the type of A. It is by default taking it as a string. Now you can see it is a string type. I need to forcefully convert this one to the integer. Either I can take first input from the user, then later I can convert this one, or either I can use this int function over here for typecasting. Int this one. Now I am saying 10. Now I want to print the type of this one. it will say me it is nothing but the integer type. Everyone got this one?
Yes, sir.
Yes, sir.
Now, in order to convert integer, I am using the int function, this int function. Similarly, in order to convert that one into the float, I can use the float function. In order to convert that one into the bool, I can use the bool function. This function I can use for the conversion. But the thing is that, if I am using this thing, a, the same function I am using, a enter number. Now my number can be 10.87. Yes or no?
Yes, sir.
But now you are able to see that it is giving me the error. Again, if my number is 12.54, again it will give me the error, because this is nothing but the string. First is taking that one as a string, then you are going to convert that one into the integer. This is the problem. So in order to avoid all of those things, we use a special type of function which is known as eval. Eval function we use with our input. So whenever I say a equal to eval input, I am saying enter something. Sorry, this is not there. Now eval function will automatically evaluate the thing and return to that a. And based on that, it will assign the data type to the a. For example, now on the screen, if I write 10 in input, it will automatically evaluate that 10 is nothing but the integer, assign that 10 to the a, and its type is basically integer. Now on the screen, if I say 10.5, it will automatically evaluate that it is a floating type of number, assign that one into the a. Now a type will become float point. In the screen, if I say a, b, c, it will automatically evaluate the type of your a, ABC, which is nothing but the string assigned to that A. Now A type will become the string. Now just see over here. Eval. Now 12 I am assigning. Now I want to check the type of your A. It is nothing but integer. Now value of A is 12, whatever we have assigned. Now again I am running this one. 10.3. Now I want to check value of A. It is nothing but 10.3. Now I want to check the type of this one. It is float. Similarly, if I say eval this thing, now I am saying a b c, sorry, the string need to give in bracket a b c. Now I want to check the type of my a. It is nothing but the string, the value of a, whatever we have assigned. So this is the magical function in the Python eval. By using this, you can take any input and that one is automatically converted into its base primitive data type. Everyone got this thing? Otherwise, you need to tell the thing that whether this input is converted into the integer, whether this number is converted into the float. You need to tell the thing. Fine? For
Yes.
eval? Now, some basic thing over there, Python. Now, in order to take the input, you are saying I can use the input function. In order to take the print the thing, you can use the function which is nothing but the print function. Print function you can use. So print function have multiple format specifier by which you can print the values. For example, if I say a equal to 10, then if I say print a, it will print 10. Now if I say print the value is, then I can say str of a, because you can not concatenate the string or number. For example, if I say Python plus 10, it will give me the error because Python this value is nothing but the string type. This value is nothing but the integer type, and concatenation between string and integer never used to be happen. That's why you need to first convert this integer value or float value or boolean value into the string by using str function. Then you are able to concatenate. Another way to print the thing is that print the value is, you can use this bracket dot format, then you can specify a. Sorry, this is not there. There are multiple notations in order to print the values. Fine for everyone?
Yes, sir.
Okay. Now we have seen our string data type. Now in the string there is a indexing is there, but for example, if I write in one str1 equal to, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm writing this thing. For example, in my string. Now, I cannot assign, as I already told you, I cannot say str1 0 equal to 5. I cannot say. This is wrong. I cannot change the value of a string, but I can extract the value from the string. Now, if I say str1 0 to -1 and 1, it will give me whole string as output. It will print 0 to 9. Now this is nothing but the slicing operator with string. This is nothing but the slicing operator with string. Now this, in the Python, you can have positive index, you can have negative index. Now in case of the positive index, in memory location, this string str1 value is basically stored in this form: 0, then 1, then 2, then 3, then 4, then 5 up to 9. Then str1 is pointing to this one. Now the index value 0, positive is from in this direction from left to right, and negative indexing is always start from right to left, in this direction. So first value having value will be 0, then this one will be 1, then 2, then 3, then 4, up to 8, sorry, up to 9, Now, whenever we are moving from right to left, the index value will change. In this case, the index value over here is -1. Then similarly, minus whatever that one, I think this one be -1, this one be -2, this one be -3, -4, -5, -6, -7, -8, -9, -10. So Python allow you to give the negative value as well as the positive value in order to extract the substring. For example, if I say in order to extract the string from your base string. Now last one is there is nothing but your step size. Now I will give you the example how the step size is working. Now my string is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Initially what I told in this one str1 0 to -1 and 1. Since my step size is 1, so what it is doing, it will first extract the 0th position. Yes, 0. Then take one increment. It is taking one increment. Then extracting the 1. Then take one increment, extracting the 2. In this way, it is forming your output string. Now, if I say -1 means up to the end, and you can use the length of your string. The length of this string is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you can use str1, 0, 10 up to 1. It will give you the same output 0, 1, 2, 3 up to the 9. Now, if I say step size str1, 0 to 10 with step size 2, it means it will extract first 0, then take the 2 step, then 2 step 0 to 2 step, it will extract the 2, then 2 step from here, then 4, then 2 step from here, then 6, 2 step from here, then 8. After that, the string is finished. Everyone got this one?
Yes, sir.
This is step size. Everyone got this one?
Yes, sir.
Yes, sir.
Now with the string, the interesting thing is like that. Just see over here. This is very important for the bioinformatician because you are extracting the substring from your DNA or protein sequence, and this is very important for the in context of your string. Now if I say this is the pattern of your string, your start is indexed, your end index, your step size. This is the way to do the thing. Now this step, again this step can be positive, can be negative. Similarly, this end index can be positive, can be negative. Similarly, this start value can be positive or can be negative. Fine. For example, in earlier example, if I say s -1, it will print your string in reverse order. I will tell you how it is happening the thing by using this notation. I will tell you. Just be with me. Now the thing is that whenever the step size is positive, always remember you need to move from left to right direction in string, and you need to convert your, if the start position or end position, whatever that one, either start or end, if it is given in negative form, convert that one into the positive form. Convert that one into the positive form. How to convert that one into the positive form? You just need to do length of your string minus the start or end index. Now what I am saying in this one, just see over here how it is working. Now take one example. S equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of your string is 10. Now I am saying S start with 0. By default value of this one is nothing but your length of string. By default, if we are not providing the end index, and by default of the value of this one is 1. Now I am saying start from 0, go up to the length and do the step size one by one. So basically it will extract, the thing is like that, S start, and in case of positive step size, I am saying this example is related to the positive step size. So the step, so the substring whatever it extract, that one is nothing but 0 to, sorry, start to end minus. Now in this one, length is what? 10, and indexing is what? 0, 1 to 9. So 0 to 9 index with step size 1, it will extract. So the output will be 0, 1, 2, 3 up to the 9. Fine for everyone?
Yes, sir.
Now again, see over here, I say 0 to 6 with step size 1. What will be the output?
0 से till 7 तक 0 1
What will be the output?
5 7 6 7
0, 1, 2, 3, 4, 5.
0 to 5, because end minus 1. End minus 1. So 0 to 5 index, it will extract 0, 1, 2, 3, 4, 5. 0 to 5 will be the output. Now, if I say S0 to 6 with a step size of 2, what will be the output?
0, 2, 4.
Yes, 0 to 4 is the output, because it need to move to 2 step in order to extract the things. Now, I am saying over here, S2 to minus 5 with step size 1. Just follow the earlier one, what I told you. Try to convert that one into the positive index. What will be the output? So just see over here,
2 to 4
the step size is positive. Whenever the step size is positive, we need to move from left to right. In this direction, we need to move in our string. Now, our start index is our 2. Start index is 2. Now end index is negative number. So whenever our step size is positive, we are moving from left to right. Since our end index is negative, what we do? We need to convert it into the positive. How we are going to convert that one? By subtracting the length of string. 10 minus 5. What is that?
5.
5. Yes, so the whole problem is come out in this way. 2 to 5 with step size 1. Now tell me what is the output? Now what is the output?
2, 3, 4.
Just 2, 3, 4. Why? Because it will extract from start to end minus 1. Fine for everyone?
Yes, sir.
Yes, sir.
Again, if I say another thing, I will write the thing in terminal also. If I say a equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I am saying a minus 9 to 6 with a step size of 2. What will be the output?
1, 3, 5, 7.
Just see over here.
No, 1, 3, 5.
Just see, I am running this one. What will be the output? 1, 3, 5. So, how you are getting this one? S equal to minus 9 to 6 with a step size is what? 2 with a step size of 2 with a step size of 2. Since it is a positive one, so we need to move from left to right. So this one is the negative, this one is the negative. So we need to convert into the positive. 10 minus 9, which is nothing but the 1. Now the whole thing is converted into the 1 to 6 with a step size of 2. So it will extract 1 to 5 with a step size of 2. 1 to 5 means up to here it will extract. So it will extract first 1, then 3, then 5 is the output. So everyone got this one. If I say one more example in this one, I say the same thing, s minus 6 2 minus 9 minus 6 2.
1, 3.
So everyone getting this one.
Yes, sir.
Now if I say the thing is minus 6, mm, minus 1 to minus 6 with 2 step size.
Nine, 7, 5. नहीं 9 7.
The output will be blank. You can see over here. Now how it is giving this blank output? Just see this one. Why it is giving you the blank output? Now what I asked in this one, S what is that? S minus 1 minus 6 to minus 1 to minus 6 to. Since the index step size is positive, therefore in the string I need to move from left to right. Up to here is fine for everyone? Yes? Yes or
Yes, sir.
no?
Yes, sir.
I need to move from left to right. Up to here is clear. Now the index is negative. Index is negative. I need to convert it into the positive form. So I need to subtract with the length of string. So 10 minus 1 will become 9. This will become 10 minus 6 is how much?
4.
4. This will become 2. Now, what is the thing is that start to end minus 1, it will run. So it will try to extract the thing from 9 to 3. And we need to move from left to right. Now the ninth index is what? This one? Yes or no?
Yes, sir.
So you need to move from left to right. Now if you move in this direction, will you get 3 or not? Third index or not? Never. Because 9, 10, 11, 12, it will be in this fashion, increasing fashion. You will never get 3. That's why it is giving you the blank output. So you need to do this thing with carefully. That's why I gave this example. First, you need to remember where I need to move from left to right. Okay, I need to move from left to right. Now the index are negative. I need to convert it into the positive form. Yes, I converted that one. Then I need to move. After converting that one, I need to extract start to end minus one. Now while traveling in the string, I will never get 3 while moving from left to right. That's why it is giving me the blank output. Now the fine, everyone is fine with this.
Yes, sir.
So come to the negative step size. Now string is over like that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our string. Now the format is like that. Start, end. Now the step size I am giving in negative form. Now in this case, whenever I say the thing step size is negative, I need to move from right to left. I need to move from right to left. In this case, whenever the index step size is negative, my start by default is minus 1 and h, my length of my string plus 1 and my negative index size. For example, if I say s equal to minus 1 or minus 1, or I can leave this one also. So whenever our index size is or step size is negative, the default value of start is minus 1 and value is length of string plus 1. That one is the negative form. So in this one, since the step size is negative, I need to move from right to left. And my starting position is minus 1. My starting position is minus 1. So in this case, whenever the step size is negative, it will extract the string from start to end plus 1. In case of positive step size, start to end minus 1. In case of negative step size, start to end plus 1. And by default, this end value, in this case, whatever the length of your string, which is nothing but the 10 plus 1 is minus 11. Your string length is minus 11. So it will try to extract the thing s to e minus 1, s is minus 1 to 11, sorry, end plus 1, minus 11 plus 1. So minus 1 to minus 10. It will extract. So its index is minus 1, its index is minus 10. So your output will be in reverse order. Up to here is fine.
Yes, sir.
Now in this one, whenever the step size is negative and these index are given in positive form, try to convert that one into the negative form. How you are going to convert that one into the negative form? You need to subtract start or end index by length of your string. Earlier what we have done? We are subtracting the index with the length of the string. Now we are subtracting, earlier what we have done? In case of positive step size, length of string minus start or end. Now over here the thing is changed. We are subtracting the index with length. The thing is little bit changed because we need to the index in negative form. Got this one?
Yes, sir.
Now take one example in this one. Now, if I say s equal to minus 1 minus 6 with a step size of minus 1, what will be the output? What will be the output? Anyone? So anyone can tell me the output of this one?
Four, three.
So just see over here, the step size is negative. So I need to move from right to left. I need to move from right to left in string. Now all of those things are in the negative form. It's fine for me. So it will be minus 1, it will be minus 2, it will be minus 3, it will be minus 4, minus 5, a minus 6, minus 7, minus 8, this one will be minus 9 and this one will minus 10. So what it will do? It will extract first minus 1, which is nothing but the 9. Then do the adding of this one, that is step size to the first index, which is nothing but minus 1, minus 1, minus 2. It is 8. Then 7. Then 6. Then 5. Since I already told you, this one will be end plus 1. So it will extract the string from -1 to -5. So output will be 98765. Output will be 98765. You can see over here. Everyone got this?
Yes, sir.
Now just check this one. If I say this thing S equal to 1 to 6 with a step size of -2. Tell me the output.
864.
Hmm?
864.
864. Anyone?
975.
975. Now just see over here. The step size is negative. So we need to move from right to left in this direction. Fine. Now the index are positive. We need to convert them into the negative form. So we will subtract with the length of a string. So 1 minus 10 is minus 9 for this one. 6 minus 10 is how much? Minus
4.
4. 6 minus 10 is minus 4. So it will become out like that as minus 9 to minus 4 with step size of minus 2. So what I told you in this one, this will extract the string from start to end plus 1. So basically it will extract the string 9 to minus 3 up to here with step size of 2 end plus 1. So just see over here, this is the minus 9 index, and while moving to the right to left, will you get minus 3 over here or not? In this direction, will you get minus 9?
No, sir.
After this minus 9, will you get minus 3?
No.
That's why the output of this one will be the blank. If you want to check this one, just check over here. A 1 to 6 with step size of our minus 2, the output will be blank. Use the same concept again and again. First, check for the positive one. The summary is something like that. Step size. Step size is, if it is positive, either it can be negative. If it is positive, you always need to move from left to right. If it is negative, always need to move from right to left. And if the start or end is negative in this one, you need to convert that one into the positive. By how you can do that one? You need to subtract length of string minus start or end. Over here, you need, if the index are positive, you need to do start or end minus length of string. And the general form is that always you need to extract the thing from start to end minus 1 over here, and over here start to end plus 1 with your step size. If step size is 1, then start plus 1, start plus 2 will become to the output. If step size is 2, then output will be start plus 2, start, and then start plus 4. In this way, it will come into the output. And always keep in mind, you need to keep this direction in your mind while you are extracting the thing. Fine for everyone?
Yes, sir.
Yes.
So after this one, we'll meet at 3 o'clock. I'll be sharing some assignment to you. Meanwhile, you can do that one. This one, that assignment is basically covering that concept up to where I taught you till now. So do that one. We can discuss. We will be going to discuss that one at 3 p.m. And later on that in this one, we'll move to the advanced data structure and functions within the Python.